Yesterday hurt my brain. Today, huh, here we go. You guys could write down the question of the day. What is out there past our own Milky Way galaxy? I want you to keep in mind our galaxy is huge. We've never been outside of it. We can only see very, very small, maybe 5% of it with our naked eye. Our galaxy is huge. And now we're trying to talk about what is outside of our galaxy. Let's jump right into it. We have a group of galaxies that are all nearby us in the Milky Way, and we call that the local group because they're pretty local to us in terms of the entire universe. So the local group is this right here. It's got over 50 galaxies, including a bunch of dwarf galaxies, which are little tiny galaxies. Our galaxy might have 200 to 400 billion stars. These might have, 5 billion. So dwarf galaxies are a little bit smaller. But there's over 50. The other largest galaxy that is in our local group is known as the Andromeda Galaxy. In fact, it is the only galaxy that you can see with your naked eye. Andromeda is about 2.5 million light years away. This is the galaxy that Henrietta Swan Leavitt found a Cepheid variable star in and was able to calculate how far away that star is. So now we know how far away the entire galaxy is. And it is hurtling towards us. And in about 5 to 6 billion years, the Milky Way galaxy, the Andromeda Galaxy, are going to smash into one another. Right about the time when the sun goes into a red giant phase and swallows Earth. However, when two galaxies collide, the stars are so incredibly far apart that they usually just pass right through. There are going to be a few star collisions, but for the most part, it's mostly empty space out there, so they pass right through. If you were to take a look in the constellation of Andromeda, you would see the Andromeda Galaxy. In fact, it looks like a little fuzzy blob. This is the central bulge. You can only see the very center of it. The rest of it's too dim. Here's another photo of what you would see. It's very hard to distinguish from other stars, other than the fact that it looks kind of like there's a cloud around it. It got its designation M31. Messier was an astronomer a few hundred years ago, and he started cataloging all of the things that he could see that were not stars. Didn't necessarily know what they were, but they weren't stars. A lot of the stellar nebulas have an M in front of it because they were in the Messier catalog. Well, this is the 31st thing that he cataloged. M31 is the Andromeda Galaxy. It's an entire galaxy. It is the only thing outside of our galaxy that you can see with your naked eye. This is what you see with your naked eye, and it looks like it's just a little star in a cloud of gas and dust. If you use a long exposure camera, you can see a little bit more of the outer regions of this galaxy. But if you could see the entire thing, it would look like this. It would be much bigger than a full moon would be, because the Andromeda Galaxy is huge and is relatively close to us. If you would like to find the Andromeda Galaxy, all you need to do is find the Andromeda constellation. And remember, a constellation is not necessarily the picture anymore, but it is the area of the night sky that those objects are in. Andromeda Galaxy is in the area of the night sky known as the constellation of Andromeda, just above the best constellation of them all, which is Triangulum. And in between Andromeda and Triangulum is M33, which is another Messier object. I want you to keep M33 in your brain. We're going to get back to that in just a few seconds. And now, to go off on a little bit of a tangent, if you could see the entire Andromeda Galaxy, this is what it would look like. Obviously, the moon would pass in front of it because the moon is closer. But think of the things that would be different. Religion would most likely change. For a very long time, religions, there's a lot of them based on the moon and the sun. And if all of a sudden you had something in the night sky bigger than the moon, there would almost definitely be religions based off of the Andromeda Galaxy. Astronomy would be different. For the longest time, we thought that our galaxy was the entire universe. We didn't think that there was anything outside of our galaxy. It wasn't until like the turn of the century that we started realizing that there was stuff farther away than our galaxy. Well, if you could see all of Andromeda with your naked eye, astronomy would have been advanced by hundreds of years, which means science would also have been different. our worldview. So the way that we view ourselves as humans in the universe would have changed. We would have realized sooner that humans are not the center of the universe, although some people still think that we are. Navigation would have changed, because this is a lot easier to see than some stars that could easily be covered by clouds. And then things like fairy tales and stories and myths, there would be a whole bunch of them based off of the Andromeda Galaxy. So sometimes I like to just think, if one little thing was different, you could see the Andromeda Galaxy, how many dozens of ways would our lives be different? Religion would be different, science would be different, stories would be different, navigation would, like, all if we could just see this one galaxy. I don't know, I like to think about that kind of stuff. Who is in our local group, our little gathering of close by galaxies? Well, we have the Andromeda Galaxy, M31, with a bunch of little dwarf galaxies around that. We have our Milky Way. This is a photo of the Milky Way from inside, because we don't have a photo of the Milky Way from outside. So this is looking towards the center of the Milky Way. We have M33, which is the Pinwheel Galaxy. I mentioned that before. It is a perfectly circular, very photogenic galaxy. M33 is down here, a little bit farther away than Andromeda Galaxy. And then we have the Large and Small Magellanic Clouds, which are two little dwarf galaxies that you can see from the southern hemisphere. Obviously, this is the Large Magellanic Cloud, and this is the Small Magellanic Cloud. And even though this is called the local group, which makes it sound like these things are right next door, they're only next door when you compare it to the universe. These objects are many, what is this, 100,000 million, billion, trillion, quadrillion, 22 quintillion kilometers away. We're not going to travel there anytime soon. So these distances are huge. And this is intergalactic space. So you have interplanetary, like between here and Mars. You have interstellar, between here and Betelgeuse, but still inside of our galaxy. And then you have intergalactic space, which is this space here in between galaxies. If we were all in class, I would take a tennis ball and stick it through the center of a paper plate, and I would have somebody stand up at the front of the room. Then the Andromeda Galaxy would be roughly the same thing, but at the back of the classroom. The Magellanic Clouds would be two little ping pong balls off to the side of the Milky Way Galaxy. We would take two little bouncy balls and put them in the back of the room next to Andromeda, one in front, one behind, to represent those little dwarf galaxies that are over by Andromeda. And then the Pinwheel Galaxy, M33, would be a smaller little paper plate that is off a little bit farther away than where Andromeda is. If the Milky Way is positioned like this, then Andromeda is positioned like this, a little crooked. The Pinwheel Galaxy is like directly facing us, which is why we can see the full pinwheel or the full spiral of that galaxy, because it's on a different plane than we are. And then I'd pass out marbles to the rest of the students. Those little marbles would represent all of the other little dwarf galaxies, because there's over 50 in total. We would do this as a class activity. I hope that you guys have a good imagination, because we obviously cannot do that. This is what should be in your brain. You have the Milky Way Galaxy and the Andromeda Galaxy, the two largest galaxies in our local group. Each one has a bunch of little dwarf galaxies that surround it, with a bunch of space in between. Down here, off to the side of Andromeda, is the Pinwheel Galaxy, which is the third biggest object that's in the local group. If you notice, a lot of these dwarf galaxies are actually just named after the constellation that you can find them in. So you have the Sagittarius dwarf galaxy, the Draco dwarf galaxy, the Ursa Minor dwarf galaxy, Leo 1 and Leo 2. So they're really just named after their location in our night sky. And now we're going to zoom out. This is intergalactic space. This is 2.5 million light years. This is our local group. But when we zoom out, what do we see? Our local group is like a speck. There are other groups of galaxies, other clusters of galaxies that are much bigger than our local group, than our 50 or so galaxies. And if we thought Andromeda was far away, like these are out there. So let's talk about how we arrange galaxies. The smallest little organization of galaxies are called groups. Our local group is an example. Usually about 50, maybe up to 100 or so galaxies If you're bigger than just a group of galaxies, 50, 100, maybe 200 galaxies, you're a bigger conglomeration or collection of galaxies. The next name that we have for you is a galaxy cluster. And the biggest nearby galaxy cluster is known as the Virgo cluster because it's in the constellation Virgo. It's about 50 million light years away, and it is a collection of over 1,500 galaxies. So our local group has 50, and this galaxy cluster has got 1,500. And you'll notice that if you're a little tiny amount, you're known as a group. But if you are a large cluster of galaxies, we call you a galaxy cluster. And you might think, so what if you zoom out some more? What would we call all of these groups and clusters together? We would actually call that a supercluster. And we are part of what's known as the Virgo supercluster. Why the Virgo supercluster? Because it's named after the largest cluster in that supercluster. And if you take a look, the largest grouping of galaxies in this whole thing is the Virgo cluster. So this entire supercluster is named after this. We are part of the local group, which is part of the Virgo supercluster. All of these galaxies are part of the Virgo supercluster. This is 50 million light years, so the Virgo supercluster is almost 100 million light years across. Now let's zoom out. Starting here, hopefully you recognize this. Earth is huge. Here we are in Orlando. Think of driving to Miami. That takes a while. So just wrap your head around how incredibly giant Earth is compared to you. And then we're going to zoom out to our solar system, and you can't even see Earth anymore. Like if you go out and include the Kuiper Belt, past Neptune, out where Pluto lives, you can't even see Earth. So we have zoomed way out to the point where you can't even see individual objects anymore, except for the sun. Now we're going to zoom out from our solar system to the closest stars. You can see our sun is right here at the center. You've got Vega, Aldebaran. So the closest stars are in our interstellar neighborhood. These are the ones that if we ever wanted to travel to, maybe 100 or 200 years in the future, we're going to go here because these are the close by stars. Let's keep zooming out, and all of those stars that are close by are in like a little tiny circle, about that big. What we can see with our naked eye is inside of this little tiny circle right here, to our huge spiral galaxy. This isn't exactly correct because there should be a little bar here, but you can tell that our galaxy, 100,000 light years across, with 200 to 400 billion stars, is absolutely massive. It's huge, giant. And that's our galaxy. We've never been outside of it. We can never hope to travel across it. It's just big. And if we zoom out from our Milky Way to our local group, we have the Milky Way here, the Andromeda Galaxy, the Pinwheel Galaxy. We have the Large and Small Magellanic Clouds. This is our local group. Let's keep zooming out. Our local group, if you zoom out a little bit more to our Virgo supercluster, all of a sudden, you can't even see our local group. Our local group is now too tiny to even see. So here is the Virgo cluster. So this entire collection of stars is known as the Virgo supercluster. And I believe this little group of stars right here is our local group. So the Virgo supercluster is pretty big. Let's keep zooming out. These are our local superclusters. The Virgo supercluster is right here. I don't know if you can see it or not, but our supercluster, it's super tiny compared to some of the nearby superclusters. So these are the nearby superclusters, which they're far away. Let's keep going. So our local superclusters are this little dot right here. I don't even know how to explain how big the universe is. I know I'm an astronomy teacher, but Still can't do it. After 6 years, you'd think I'd find a word, but starting from Earth to our solar system, to our close by stars, to our entire galaxy, to our local group, to our supercluster, nearby superclusters, to the observable universe. All right, have a good one.